Here's what the bottom of the keel looks like so far. And then on this end, it's got the space for where the rudder piece is going to come through. The way it goes together is this part of the keel, the top part, would be flipped over, put on top of there, and then it goes onto the boat. The reason I've got them in two separate pieces is so that I can more easily transport them. Once I'm at the boat yard, then I'll put them together down on the ground and then slide it underneath the boat and bolt it on to the bottom. Got it roughed out. Now it's time to screw things together. Here's a trough for the bottom part of the keel, which is right here. I've got these wooden plugs filling the holes on the bottom to try to keep the tar from completely filling the bolt hole. This is tar paper I had left over from a roofing project I did about 15 years ago. It's a bit dry, but it should work. My hope is that when I pull the bottom part of the keel out of this trough, the tar paper will come with it and I can just sand it off or maybe even peel it off. I've got this wooden block taking up this space in the back where the rudder mount is going to go. The reason I'm going to submerge it in tar is that I would have to weld tight a whole bunch of places where the bolts go through. Instead, I'd rather just have the tar go inside and cover everything. Hopefully there will be enough tar to fill the empty space of this whole bottom part of the keel. The reason I'm not going with the welding is because it's very difficult to make a watertight weld, and if it leaks even just a drop every week, that's enough to eventually fill it with water and rust it out from the inside, which I'll never see. On the hull, if any of my welds are bad, I'll see that and I'll be able to fix it. But this will be always underwater and I won't know until it's too late. So that's the theory. If I fill it with tar, it should last a little bit longer. A week ago, I tried to get some more coal tar epoxy from Jamestown Distributors. They need another 2 weeks just to get it into their shop, and another, I don't know, 3 days to a week to ship it to me. So that'll put me well into the end of February before I actually get any. So, since all I'm doing is trying to protect the bottom of the keel, then I'm going to try making my own. This is roof tar. I'm going to put some fiberglass resin in it, along with some paint thinner. I should use Xylol because this evaporates slower, and it does seem to mix with the tar better. I've already done some tests. Here's how it came out. This is regular roof tar. This is with the resin in it. It's just a little bit stiffer. It's hard to tell in the camera. This is about 3 gallons of roof tar with half a gallon of paint thinner. I like the way it's moving now. So I'm going to switch to the fiberglass resin and I'm going to mix it with its activator in this jug. And then I'm going to pour it in here because I think that if I don't mix it independently, it won't reach the activator. The activator won't take effect on the resin. So I'm going to take a chance with that. It's about 55 degrees right now, so I think I've got at least a half an hour to work with the resin before it goes off. This is about a quart of resin. I've already mixed it with the activator. With coal tar epoxy, it calls for 1 quart of resin type material for every gallon of tar. So this is only 1/3 that ratio. I've got 3 gallons of tar, but I'm not going for a super hard end result. All I want is something that's a little bit stiffer than the roof tar. It's resting in the tar now. Can't really see it, but it did press out to the sides a little bit. I made a nice tight fit with this trough. And now I'm going to pour a bunch of it into the nose. And hopefully that will settle in and go all the way to the back. I might tip this up a little bit to give it some assistance. It will flow by itself, but so slowly that I don't want to spend the time waiting, so I'm just pushing it through with the stick. The level of roof tar epoxy in there has gone down about an inch already, so I know it's flowing. Should get some of it to flow down the length of the keel bottom, and then after, let's say, an hour, I think I'll put it back down so that it flows slightly this way. I won't know the results of this experiment until about a month from now. I'm actually planning on letting it just sit there for a month because I can do a lot of other stuff in between, and that'll give it a chance to get as hard as possible. I'm going to try to fill up the whole inside of the bottom part of the keel. So I'll probably pour some more tar in there, maybe some paint to fill in anywhere that the tar couldn't get to. This tubing is just a little bit too small. What I want is for this race to fit inside of there. So I'll just cut off a piece that tall, and then I'll cut a slot and fit this in. Not bad. Here are a whole bunch of pieces of scrap oak that I'm hoping to turn into the tiller. Despite being as careful as possible, these were the best joints I got. It'll work. And of course, I glued it to the plywood by accident. There we go. Here it is after a rough sanding. I've left this part flat in back so that I can put a piece of metal around it. Most of these pieces used to be part of a kitchen cabinet remodel that they tore out, so stuff like this got left inside of it. I don't really care. I could fill it in, but it doesn't bother me, and I like the idea of seeing what it used to be. I can't show you the whole thing because I need the boat to be another 4 feet higher from the ground in order to install the rudder, because the keel's not on right now. But here's how everything's going to go. This fits on there. Then this lid fits on top of the rudder box. This bearing race fits inside of here. It's a tight fit, so I'm not going to push it in right now. And then the bearing fits on top of that. This will fit on approximately here. It's a tight fit also, so I'm not going to put it on. Then you'll have these two pieces The purpose of these two pieces is not to bear any weight, but just to rub against each other so that they make a good seal to limit the amount of water that might splash up through the rudder box and come through to hit the bearing. This piece is screwed onto here. This piece is screwed onto the bottom of here. That goes on. So now we're attached to the lid. And then I can't put this piece on either because it's a really tight fit. And that will fit inside of there. On top of that, go this piece. That'll hold the bearing in place and rest all the weight of the rudder on here. And then this goes on here. It's also a tight fit right now, so I won't be putting it all the way on. This is where the tiller attaches. The tiller is right here, but I can't put this on it yet because I just put some finish on it. It'll be about this deep inside, and I still have to drill some holes to put some bolts on. And you'll note that the rudder is actually going to sit like this, so the width of it is going to sit the other way, and that'll give it the most strength left and right. Up and down it hardly needs any strength at all.